Hello folks, I'm just going to have a quick look at some of these particles in solution. One or two viewers asking me to make a quick video explaining a couple of the more difficult parts. To be fair, the book is not the easiest book in the world and it can be a little bit hard to follow. So if you have any questions, just post them on Google Classroom. I'll answer them and I can try and do up a video when I get a chance. Also, I'm recording this around 10 o'clock. But I should be able to upload it in the morning. So let's have a quick look. So what we're looking at here is CW6, and this is where you should be able to investigate the properties of different materials, including, and then we've got our solubilities, conductivity, melting points, and boiling points. But before we start all that, you have to get an idea of the basics. So the first one we're going to look into is a couple of words. We're going to look into the word solvent. We're going to look into the word solution. And we're also going to look into the word solute. So you need to know the difference between these. So let's take, for example, let's say we have a cup of water or a beaker of water, whatever the case might be. So we're going to label this as water. This is called the solvent. And the solvent is the substance that you dissolve something in. So you dissolve something in this. Now, what are we going to dissolve? So why don't we take maybe, I don't know, let's take salt. I suppose is the example that's always used. So we're going to take the salt and we're going to pop the salt into the water. When we pop this in, this salt is called the solute. And this is the substance we are putting into the solvent, and it dissolves. So that's what you have to understand what each one of those words means. Now, the result is where you end up with water in your beaker, and you end up with salt in this. So when it dissolves down, the salt is mixed in like that. The reason why you can't see it, the reason why it's dissolved, is all these salt molecules manage to fit in the gaps of the water molecules. So you've got bigger water molecules here, and the water molecules surround the salt molecules. And because they're surrounded, you can't see them. Now, just because you can't see them doesn't mean they're not there. If you actually drink up that cup of salty water, you'll know all about it. So just because you can't see them doesn't mean they're not there. The water is completely surrounding it. And that's what it means to be dissolved. Now, this substance is what's called a solution. So it's important to know that a solution is the solvent plus the solute. And that's the first step of something that you need to know when we're talking about these. So the next thing we're going to take is we're going to have a look at this particular part here. This is the solution. Just going to see if I can copy that. And I should be able to paste it and bring it down here out of the way so we can talk about the next thing. So in this particular example, again, we have the water surrounding the salt molecules. So these blue things are water molecules. So the next thing that we're going to have a look at is saturated compounds. So the saturated compounds are fairly straightforward. You could have a beaker like this where we have salt molecules surrounded completely by water molecules, and you won't see the salt molecules. However, if you keep adding salt molecules, what you'll end up happening is all the gaps will be filled in. Any gaps that were available in between the water molecules are now filled in with salt molecules. So the only place the salt molecules can now go is down to the bottom of your beaker or cup or whatever it is you're drinking from. And in here then you have your standard water, which is in here. And of course you have a little bit of salt dissolved in. But if all the gaps between the water molecules are full, there's nowhere else for the salt to go but to go all the way to the bottom. And this sits at the bottom of the mug. This is what a saturated compound is. So a saturated compound is when the solution, which is the two things together, when the solution cannot hold or dissolve any more solute. So that's what we say when we come in out of the rain, oh, we're saturated. What it means is it doesn't matter if I stand out in the rain for another 3 hours, I couldn't possibly get more wet. And that's what this is here. So this here is now a saturated solution. And often in science, especially in chemistry, you'll have to make saturated solutions where the solvent, in this case, which is water, cannot hold any more solute, which is the salt, and it becomes a saturated solution. So that's the main difference between solution, solvent, solute, and what a saturated compound is. What's the opposite of a saturated compound? Well, the opposite of a saturated compound is, or saturated solution, should I say, is dilute solution. I suppose if you wanted to be accurate, this one here would be saturated solutions. I wanted to make that clear. So what's a dilute solution? So the dilute solution is the opposite of this, where you have your beaker, you have your water, but in this case, you only have a very small amount of salt molecules. So this would be a dilute solution. So there is less solute than solvent. So you can say, therefore, solute can dissolve. And all it means to dissolve is slip into those spaces in between the water molecules and completely surround them. And that's what a dilute solution is. Okay, so the next thing we're going to look at is soluble and insoluble, because not everything is soluble. So obviously, if you take something like water and salt, so water and salt. In this particular example, water and salt, or water and sugar, or water and, I suppose, anything else, diluted orange. You know, if you take something like that, or Ribena or something, all of these substances here are all soluble. However, if you decide to take water and another substance like sand, so water and sand, or water and oil. Again, if you've got some vegetable oil or olive oil in the cupboard at home, go and have a look at it. If you've got a bit of sand, throw it into water and see what happens. These are what's called insoluble, which means they don't dissolve down. They sink straight to the bottom. So they go to the bottom, generally. There are exceptions to this. Obviously, oil doesn't go to the bottom. And that comes up in a chapter later on called density. So they're insoluble as opposed to soluble. So the first thing that we're going to look at is how to separate something like sand and water. Now, sand and water, sand doesn't dissolve in water, so it makes it quite easy. Let's have a look at this experiment. The videos I sent you in the link have got this detailed, but let's just have one more quick look at it. Let's have a beaker, and we have another beaker then, and inside in this beaker we have water. We have water, but we also have sand. And we'll put sand in here in red. So this is our sand. And of course it is in water. So what we do is we get a funnel, and again we would have been doing this in the lab if we were in school. So you've probably all seen a funnel before, and it tips down like that. And inside in the funnel, what we do is we put a piece of what's called filter paper. Now, some of you may have filter paper at home, coffee filter paper, and if you do, you can try this by folding the coffee paper. So what I'm going to do is I'm just going to put in green here. I'm just exaggerating it here a little bit. This thing in green here is what's called our filter paper. And filter paper is paper that has small little holes in it. So instead of being a solid piece of paper, it's got really, really tiny microscopic holes. And those holes are big enough to let water molecules through. However, they're not big enough to let sand through. So what happens is when you pour your water and sand mixture into the filter paper, what ends up happening is you end up getting water at the bottom. And as you pour in, obviously the sand is going to go in, you're going to be left with sand here inside the filter paper. And all the water will run its way down. And this is the first separation technique that you've got to be able to do. Just separating two substances from each other. Now that's separating two substances that don't dissolve. So what happens if you have two substances that are dissolved, like salt and water? If you put salt and water into this funnel here, both the salt and the water will go into the bottom. So how do we fix that? The next one then is going to be how to separate salt and water. And this is actually very simple, this first part of this. All you've got to do is you take your beaker or your cup and you fill it with water. Your salt is dissolved in the water like that, and it's surrounded by it. All you've got to do is heat it. So you put it on some sort of a hob or a hot plate that we would use in the lab, or you can put it on a cooker at home, whatever the case might be. So there's your hot plate. And you're going to turn the hot plate or the hob up to 100 degrees or greater than 100 degrees Celsius. And what's going to happen? Well, the water is going to turn from a liquid into a gas. In other words, it's going to turn into steam. And what will happen is the water will keep boiling and it will eventually disappear. And all that will leave you with is at the bottom of it, your salt. Now, where's the water gone? The water, of course, has evaporated off. And this now is what we call water vapor or steam. And this is now in the surrounding air. So that's how to separate salt and water. Where the problem occurs is what happens if you want to separate salt and water, but you want to keep the water. How do you keep the water at the end? And that's the next experiment we're going to have a quick look at.